So here we go. Suppose you want to deposit $1,000. See? So the P0 is given to you straight up in the beginning. And look what they ask you. What continuously compounding annual interest rate should you look for if you want to make $1,500 in 10 years? Okay? So another way to put this is find a bank that has some interest rate, and that bank will allow you to make $1,500 in 10 years. So you know your goal, you know how much money you start with, and you just want to find a bank that'll meet that goal. Okay? So we're going to start out just like we did before. We know that the bank is going to compound it continuously, or at least we're looking for a bank that'll do it compound the interest rate continuously. So we know that the function is going to look like P of t equals the initial, which now we know is $1,000, times e to the r. Notice how I write r because this time I don't know it, then t. Aha, but we know that we want to make $1,500 in 10 years, so 1,500 should equal 1,000 e to the r times 10. Okay, and look, this is the thing we want to solve for now, the interest rate. And so in order to do that, we have to take 1,500, divide by 1,000, and then we're going to get 1,500 divided by 1,000. Okay, if you simplify that, you see you could cross out some of these zeros. 15 divided by 10 is the same thing as 3 over 2. I'll write that later though. This is equal to e to the r times 10. And we come over here, we get 3 over 2, I won't write anything in green now, is equal to e to the r times 10. See that 10 is in the exponent. How do you solve for that r? Remember, you have to take natural log of both sides so that r comes down. It'll come down with the 10 also. So we'll have ln 3 over 2 is equal to r times 10. And so finally, r is equal to ln 3 over 2 divided by 10. And if you plug that into your calculator, you will get 0.0405, or in other words, 4.05%. Okay, so see, the thing we solved for is different. We solved for the rate, and notice that if we want to solve for the rate, since the rate is in the exponent, somewhere in the equation we're going to have to take log of both sides to get it down. Okay, last problem. We're going to do the same exact problem, except instead of continuously, the interest rate getting compounded continuously, it's going to get compounded monthly. And you'll see this is a little bit more technical, all right, at least computationally. But the procedure is the exact same thing, okay? You know this time that the exponential function has to look like 1,500 times 1 plus the rate, which we don't know, but we know how often it's getting compounded, so we divide that by 12. And we raise everything to the 12 times t, the power t, okay? And so, since we want to make $1,500 in 10 years, we know that 1,500 has to equal, my bad, we started out with 1,000. Yeah, I just looked at the wrong number. So let me just erase that really quick. So we started out with 1,000. There we go. And we want to make 1,500, all right, in 10 years. So 1,500 should equal 1,000 times 1 plus the interest rate, which we don't know, divided by 12, raised to the 12 times, notice here, 10 power, because 10 is the number of years we want to make $1,500 by. Okay, so you see when we solve for this, that r now is sitting inside here. It's not in the exponent anymore. So look what happens. It's a little tricky. We're still going to divide both sides by 1,000, and so we'll get 3 over 2, just like last time. And look here, we're going to get 1 plus r divided by 12 to the 120th power, right? And now we have to take ln of both sides because we need to get rid of this exponent. So we'll get ln of 3 over 2 is equal to, watch this, using log rules, 120 comes down, and we'll get ln of 1 plus r divided by 12. So r divided by 12. And now we divide both sides by 120, so we'll get ln 3 over 2 divided by 120. This is equal to ln 1 plus r divided by 12. And I'm just going to write out this number for you. The calculator spits out the number 0.00379. Okay, I rounded it to the fifth decimal place. Okay, but look at this. That number is equal to ln something, and the r is inside the ln. So we need to get rid of ln. So how do we do that? This time, so we have to raise e to both sides. Okay, or raise e to both sides to get rid of the ln on the right-hand side. So it's like we took ln of both sides, but then we want to get rid of it again. So that was the tricky part. See, we need to get rid of this thing. So we'll take e to both sides. We raise e to the left-hand side. Then e to the right-hand side gets rid of the natural log, and you get 1 plus r divided by 12. And now it's really simple. You just subtract 1 from both sides, so you put this on the other side. Okay, so you'll get e to the 0.00379 minus 1. And then once the 1 is on the other side, you'll have r divided by 12. So to solve for r, you just multiply by 12. So that's equal to r. Right? So let me make a box around that. A little complicated. But you plug that into a calculator, and you get 0.0406 or 4.06%. Okay, either way means the same thing. Okay, but that's pretty much it. You see, it's the same procedure applied over and over again, but we plug in different numbers, and depending on how the problem is, for example, in this case, they were interest rate problems, things could get compounded differently. That'll tell you what exponential function you should use. And that's all.